Hello, physics. This is a question of the spring balance. It says that there are two kind of balances. One is called vertical spring balance, and this is a longitudinal lever balance. The mass can be measured on Earth by using these two balances. What difference would be if they are used? They make if they are used on Moon. So, what will be the difference? Number one is they are not measuring the mass; they are measuring the force. So this is the force, and this is also the balancing force. A spring balance is a Hooke's law, the force and the extension. On Earth, there will be more force. On the Moon, there will be less force. So the more force or the more extension. In Moon, there will be less force and less extension. So that will be a one thing. On a lever balance, the measurement of the moment, force multiplied by length. So there will be more force and more length. So more force, more mass, more longer arm. So these are the differences. So then there is a two things that unknown mass you have to measure this one so that if you have W1 and A1 is known, so that we have unknown B. So W1 is given, which is equal to 1.22 kg. W2 is given 1.90 kg. So W we have to measure. So W1 into A is equal to W simple into B in the first case. And then you put this one on this side, W, and W2 on the other side. So then it is the W into A is equal to W2 into B. So from equation 2, so W2 A is equal to W2 over A W over B. So this is equation number 3. A put into this first one, W1 into W2 W into B is equal to WB. BB is cancelled, so W1 W2 is equal to B square, W square, or W is equal to the square root of W1 W2, which is 1.52 kg. We can measure this one if it is unknown. Question number 3. A particle lands on a smooth, rigid, plane surface at an angle of a theta. This is theta angle, and reflect inelastically. Inelastically, that means some energy is lost as a heat or sound. So less energy at angle phi. So that means the phi angle, which is larger than the theta. So u is the initial. So u is initial, and v is the final speed. The half of the kinetic energy is lost in collision with the wall. So last energy is lost. It is imparted to the wall. With the wall. Normal component, this is the normal component, and this is the vertical component. Normal component of the velocity is reduced to under root 3 on the collision of the wall. This is the condition, very important. Show the path of the particle, and number 3, this one. Number B is write the equation and find the components. Show the path of the particles. The particle, so this is angle theta, and then this is a bigger angle, which is a phi. So this one is u, and this is v. So in if this is u, this is u. So u that will be square root u. So that is if you move this zero here and move further, then you will see this will be a triangle. So like this one. So this will be under root 2 into v. So u initial, because it's a reduced, so this will be equal to u is initial velocity is equal to under root 2 v. And this one with uh, with perpendicular, the perpendicular, this is parallel, and this is perpendicular, which is a y-axis. So u of a sine theta is equal to v of a sine theta, and in parallel condition, which is equal to this one, u first one is a cos of theta, which is equal to, this is reduced at root 3 v of a cos theta. If you square these two, u square plus v square, so this is 2 u square plus u square U square sine theta plus cos square theta is equal to V square common sine square theta plus 3 cos square theta. So this is equal to 1. So 2 u square, not V square. So 2u square. Oh, no, 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 no. That's right. So 2v square. So from here, equation 1, if you put this one here, u square, is equal to 2v square into v square, sine square is 1 minus cos square, plus 3 cos square. So this is 2, v cancel 2, and this is 1 minus cos square plus 3. So that is 2, and that will be 2 plus, and that will go on the other side, which is equal to 2 cos square minus is equal to 1. So if cos square is equal to 1 over 2, or cos phi is equal to uh, uh, under root 2, which is a 45 degree. Phi is equal to 45 degree. So now we have to find, if you substitute the phi in equation on the y-axis, so y-axis, cos of theta, u of cos theta is equal to under root 3 v of cos of phi. So phi is 45, so that is equal to, and u equation 1 under root 2 v, so v cancel. So cos of theta, which is equal to this, is under root 2. So under root 3 by 2, which is equal to cos of 30 degree. Theta is 30 degree and this is 40 degree, 45 degrees. So this is theta, and this is we have found this one. Theta is equal to 30 and phi is equal to 45 degrees. So this is the answer of this question.